question, the circuit shown in the figure was open for a long time and it is closed at t equal to 0. The current I of t at t equals 0.5 seconds is dash. For a detailed lecture on the transient analysis concepts, please refer the NPTEL video, Module 1, Lecture 17, RC First Order Circuits Complete Response with Step Inputs, Transient and Natural by Professor Nagendra Krishnapura, Department of Electrical Engineering, IIT Madras. In order to solve this problem, we need to know the formula to find out the transient current of an inductor. The transient current IL of t is equal to IL infinity, which is the final current or the steady state current, plus the transient current, which is the difference between the current that was passing before the switch was open minus the final steady state current times e to the power minus t divided by tau, where this is the time constant of the circuit. The time constant is given by L divided by R and the unit of time constant is seconds. Let's solve this problem using this concept. In this problem, the current that is passing through the switch at time t equal to 0.5 seconds is asked. So for that, we need to find out the current that is passing through this inductor during the transient state. Let us denote this current to be IL of t. Let's first find out IL of t, and then by using the Kirchhoff's laws, we can easily find out I of t at t equal to 0.5 seconds. IL of t is given by IL infinity plus IL 0 minus IL infinity into e to the power minus t divided by tau, where tau is the time constant, which is equal to the inductance divided by the effective resistance. At time t greater than 0, the switch is closed. Therefore, the circuit becomes, and to this we will plug in the inductor of 2.5 Henry. So looking at the perspective of this inductor, the effective resistance of the circuit will just be 5 ohm, because into this closed loop only 5 ohm resistor is present. Therefore, the effective resistance at time t greater than 0 is equal to 5 ohm. This implies that the time constant is equal to 2.5 Henry divided by 5 ohm, which is equal to 0.5 second. We are asked to find out the value of the current that is passed through this switch. Therefore, I of 0.5 second is equal to the total current supplied. Let us denote it as Is. So this is Is minus IL of t at 0.5 second. Let us do source transformation to convert it into a single loop of a voltage source and a resistor. So we will have a 5 ohm resistor in series with 10 into 5, 50 volt voltage source, which is connected across this switch. And we have this 2.5 Henry inductor over here. At t equal to infinity, let us find out the IL of infinity. During this time, the switch is closed and the inductor is fully charged. A fully charged inductor is just a wire, so we can replace it as a short circuit. Therefore, at time t equals infinity, the source supplies power to this 5 ohm resistor and it directly jumps into the shorted path, leaving out this path, and this circulates back into the source. Therefore, IL infinity will be 0 ampere. Let's see what happens before the switch is thrown or when time t is less than 0. When the switch is open, the source supplies power to the inductor and the inductor is getting charged. So, when inductor is completely charged, it could be replaced as a short circuit. So, just before the switch is closed, the current that passes through this will be IL0 minus, which is equal to 50 volt divided by 10 ohm. This is 5 ampere. Before the switch is thrown, when t is less than 0, the current through this inductor is equal to 5 ampere, and after the switch is thrown at steady state, this current is equal to 0 ampere. Therefore, IL of t is equal to 0 plus 5 minus 0 e to the power minus t divided by tau. We just found out that the time constant of this circuit is 0.5 seconds. So this is equal to 5 e to the power minus 2t ampere. Let's make use of this into the equation found by Kirchhoff's law in order to find out I at 0.5. I at 0.5 is equal to the current supplied by the source minus 5 e to the power minus 2t. So this is equal to 10 ampere minus 5 e to the power minus 2t, which is equal to 10 minus 5 e to the power minus 2 into 0.5. This is 10 minus 5 e power minus 1. So this comes to 10 minus 1.839. So this is approximately equal to 8.16 ampere. So this is 8.1 ampere.